Section 7.1 Estimating a Population Proportion. We cover Section 7.2. We talk about it. For the Chapter 3, we learn how to find the point estimate. Point estimate is a single value, talking about the sample mean, sample proportion, sample standard deviation, or the sample variance. And we use the single value, the point estimate, to approximate a population parameter. And starting from Chapter 7, instead of using a point estimate, we want to use the confidence interval to approximate the population parameter. For the Section 7.2, we already take care of the sample mean. We know how to construct the confidence interval for the population mean. And these sessions, we will focus on the sample proportion. We want to know how to construct the confidence interval for the population proportion. A population proportion. In this session, we will learn how to find the confidence interval for population proportion. How do you know you are dealing with a proportion problem? The distribution is a binomial distribution. There is no mention of a mean or average. On the homework or the exam, I will mess up like the order. You need to know how to construct the confidence interval for population mean, proportion, standard deviation, or variance. For the proportion problem, sometimes they never mention about what you want to construct the confidence interval for proportion. Instead, when you read the whole questions, they never mention about the mean or average or mention about the standard deviation. That will be the proportion problem. First, let's look at the requirement. Requirements for using a normal distribution has an approximation to a binomial distribution. Remember, we learned the binomial distribution on the section 5.2. Requirement is really similar. First, simple random sample. And conditions for the binomial distribution are satisfied. We have fixed number of trials. The trials are independent. And there are two characteristics of outcomes. Probabilities remain constant for each trial. We have these four requirements for the binomial distribution. It also applies for the population proportion when you construct the confidence interval. We have the margin of error also. Okay, so this is the formula. How to find the margin of error. You could see that's a z alpha over 2. This is the critical value. We will apply the same method for the section 7.2 for the part 1, how to find the critical value. And then you're going to see the P hat and Q hat here. So P hat, this is talking about the sample proportion. Sometimes they will given the sample proportion, or sometimes they will give you like the number of success. The X represent the number of success divided by the sample size. And then Q hat, that will be the sample proportion of failure. You could do 1 minus P hat here. P hat and Q hat, this is the complement. E stands for the margin of error. So the procedure for constructing confidence interval for population proportion. First, verify the requirement. Then, find out the critical value. Again, you have to know how to find the critical value on the homework and the exam. If you don't remember how to find this guy, review the section 7.2. We have an example 1 and example 2 to show you how to find the critical value. Then find the margin of error. Once you have the critical value, plug in here. P hat and Q hat and over the n. After that, you're going to construct the confidence interval. The P hat, this is talking about the sample proportion in success. You should have it in here. Minus the margin of error, or plus the margin of error. You could write your answer using the inequalities, or you could use the parentheses like this. And then at the end, draw the conclusion. You could follow this procedure using your calculator to double check your work. For the homework and the exam, you need to show me all your work. So for the calculator part, you only can double check your work at the end. Example, in a survey of 517 music teachers, 403 say that the video games Guitar Hero and the Rock Band have a positive effect on music education. Construct 95% confidence interval for the population of music teachers who believe that these video games have a positive effect. For these questions, they only say construct 95% confidence interval for the population of music teacher. They never mention about the proportion. But for the whole question, we never mention about the mean or the average or standard deviation. So you could know that we were working on the population proportion. First step, find the critical value. Okay, show me your work. We're gonna use the inverse norm 0.975. Again, when we're working on 95%, you don't just put the 0.95 in here. Okay, if you don't remember how to do it, review the session 7.2. Then use your calculator, inverse norm 0.975. You could get 1.96. Okay, step 2, compute the margin of error. So first, we want to find the sample proportion, the p-hat. So in these questions, do they mention about the sample proportion? No, right? They never mention about the sample proportion, so we may want to use the formula. Okay, one more time, p-hat, this is stand for sample proportion. The x, talking about the number of success. Right now, we want to construct the confidence interval for the music teachers who believe that these video games have a positive effect. So positive effect, that will be the number of success. So what is your x in here? We have a 403, right? 403 say that that's a positive effect on the music education. And the n, that will be the sample size, which is going to be 517. Okay, after you find your p-hat, you're gonna find out your q-hat. Use the sample proportion, subtract from 1. You should get this one. Now, plug into this formula. Use your calculator. You should get 0.0358 here. Okay. Hey, make sure when you guys use your calculator, try to plug in the whole thing on your calculator. You should get this guy. This is the margin of error. Then construct the 95% confidence interval. So you have the p-hat here, you have the margin of error, just plus minus. Okay, you should get this one. And then at the end, conclusion. Make sure you guys know how to draw your conclusion on the exam. It won't be to fill in the blanks. You need to know how to write a complete sentence. We're gonna say we are 95% confident that the proportion of the music teachers who believe that these video games have a positive effect is between these two numbers. Okay, B. A video game manufacturer claims that 80% of the music teachers believe that Guitar Hero and the Rock Band have a positive effect. Does the confidence interval contradict this claim? So think about it, they're using like 80% of the music teacher. Right now, your confidence interval here. This is 0.743 to 0.815. Means we do have 74.3% to 81.5% of the music teachers who believe that the Guitar Hero have a positive effect. And 80%, this is within the confidence interval. So we say the confidence interval does not contradict the claim. Okay, example 2. A question's a little bit different here. I want you guys think about it. What is the meaning of best point estimate? Okay, and then try to do it by yourself for the A, B, C, D. Okay, first, find the best point estimate of the population proportion. What is a best point estimate? Look at this one here. The best point estimate. The, the best point estimate is a single value used to approximate a population parameter. So the sample proportion will be the point estimate to approximate a population proportion. So we are looking for the sample proportion in here. Do you guys know the X and N? Yes, right? So you should get 0.610 here. And then B, I want to find the margin of error. Let me write down the formula. So think about it. What we're gonna do first. We already have the P hat here. We find it from the Parquet. So I want you guys find out the Q hat. You should get 0.39. And then we need to find the critical value for the 93%, okay, 93% confidence interval. So you should have a 0.965 here. The critical value, you're gonna get 1.812. Okay, plug in to this formula. Use the calculator. You're gonna see 0.0311. And then construct the confidence interval using the sample proportion plus minus the margin of error. You should get this one, 0.579 to 0.641 here. And then conclusion. So we are 93% confident that the proportion of respondents who choose the window seat is between these two numbers. I want to use the calculator to double check my work here. So I'm gonna go on the stat, go to the test. We are working on the proportion one population proportion, C distribution, confidence interval. The one here stands for one population. For the chapter 9, we do have a two population. Enter. So my X is gonna be 492 and 806. And we are working on 93%. So 0.93, go to calculate. Enter. So that will be 0.579 to 0.641. You can see on my calculator it should be 0.642 here. It's just because my sample proportion, we only take like 3 decimal space here. If we try to take like 4 or 5 decimal space, and also the critical value, if we could consider more decimal space in here, you should get exactly as Sam has the calculator here. But on the homework or exam, as long as you show me all those work, that's fine. Okay, now determine the sample size. If we wish to make the margin of error of a confidence interval smaller while keeping the confidence level the same, we can do this by making the sample size larger. So we talk about this part on the session 7.2. If we want to restrict the margin of error and we want to keep the same confidence level, so what we can do, we're gonna arrange the sample size in here. So this is how we find the margin of error. We're gonna apply the same formula. So right now, if they given the Y, you want to determine the sample size, you're gonna plug into this formula. And this is when you know about the sample proportion in success and the sample proportion in failure. If they never mention about the P hat and the Q hat, you're gonna consider that will be 0.5 and 0.5. Highlight this one. Okay, if the homework or exam, they never mention about the P hat and Q hat, you want to consider it's going to be 0.5 and 0.5. And also for the sample size, it's always a whole number. If you find it with the decimal space, you always want it up to the next larger whole number. Okay, let's try this example. First, I want you guys to write it down. What is the margin of error? The margin of error should be given, okay, the Y. And then figure out the critical value. So what is the margin of error? What's a Y equal to? You can see here, 97% confident that the estimate proportion is within 3 percentage points. Okay, highlight this one. This is talking about the margin of error is going to be equal to 3%, which is going to be 0.03. Now, find the critical value. We are working on 97%. We are working on 97% confidence level. You should got this guy. Okay, you could get 2.17. And then plug into this formula. Do you know about the P hat and Q hat? Do they mention about it? No, right? So what are you gonna put for the P hat and the Q hat? That will be 0.5 and 0.5. You should get this one. Is it your final answer? No, right? You have to one it up. Even though this is less than 5, you still one it up to the next whole number. So that will be 1,309. That's it for the session 7.1.